What's up, people, and welcome to my tutorial in Introductory to Blockchains. So in the previous, we started to introduce you guys to how it actually merges two different blockchains. Now we're going to dive into the code and see how I solve that. So this is pretty basic stuff. It just broadcasts the local blockchain to all the nodes that it knows about, and here it receives another blockchain from another node. So we're going to dive into this and see how that is implemented. So you can see here it redirects the message to the behaviors module, right? So in here you will receive the chain from the other node, and if this is running on node 1, this is going to be the blockchain from node 2. And so this is a remote blockchain, and then you also have your local blockchain right here. So now what it's going to do, it's going to start by iterating over all the blocks in the blockchain that it received to check if it's valid. And this is done in the block module and the verified chain, and then you pass in the received chain, right? So if we look at this, verified chain, so you receive a chain here, you log it out, we can remove that, and then start iterating of this. So it's gonna start on index 1, and then it's gonna grab the previous block and the current block. And what's gonna happen here is gonna do exactly the same thing that it does when it's mining it, but now we don't have to find out the nonce number because that is included in the block that it's receiving. All we're doing here is verifying that if I hash this again with this nonce, do I get the correct hash? And this is done here. So if the previous hash that we got here, when we rehashed it, if that isn't the same as the hash that was included in the block that we received, something is not right. And here we return false, that this chain cannot be valid because when we rehashed it with that nonce number, we got something else. And here, what we do is we check the current block, and we check if the previous hash of the current block is that equal to the previous hash that we rehashed. And if that is not the same hash, then it cannot be a valid blockchain because then the previous hash is pointing to some other block, right? So let's try and illustrate this again, and hopefully this will help you to wrap around your head around it, right? So for each block, you have a pointer to the previous block like this, saying that the previous hash is the hash of this block, right? So the Genesis block doesn't have a previous hash because it's the first one, but this one has a previous hash. So the previous hash, let's say that the previous hash of this is equal to 1. This hash 1. So we're checking like this is, if index I is equal to 1, we're going to be at this node in the middle, right? So we're going to grab the previous node, which is going to be the Genesis block, and the current, which is going to be the first index of the blockchain. So the first thing we do here, if I rehash everything here, is it the same thing that is in the block that I received? The second thing here is that if I rehash everything, the hash that I get is that the same hash as the previous block. That means that the link is valid all the way back. And then it iterates over checking the link, all the links, checking like, is it valid, is it valid, is it valid, is it valid? If it's broken somewhere, it's going to return false, and the whole chain is invalidated up to that point. So that means that a subsection or the whole array can be invalid, basically. It doesn't have to invalidate the whole chain, but it can validate to some degree that this subchain here is not valid. It's a broken link somewhere. And this is what this does. So if you go back here, if we receive true here, we know that the chain is valid, right? But if it isn't valid, we exit prematurely here and then say that you have a bogus blockchain and I'm going to continue using mine because this doesn't make sense. And then it's going to return the blockchain that I have, so the other node can update it if it like. Maybe it's corrupt or something that it needs to update the blockchain of someone else, right? And then check like the chain that I received, is the length of that chain exactly the same, or is it, in this case, is the received chain longer than the chain that I have? And if it is, basically that means that someone else has a longer chain than I have, and I need to swap them around. So I need to include, say that the received chain is now my chain also, because it was longer than the one that I had, which means that I'm missing transactions. So in that case, I just say that, okay, this chain is also mine. But if they have the exact same length, then it's getting a little bit more interesting, because they can be the same chain, but they can also be different chains with the same length. And that is what I check here. I grab the last hash of the chain and check. The last hash, is that the exact same hash as the last hash of my chain? And that means that I don't have to check the whole chain. That is the nice thing about this. If I have two concurrent chains like this, and I hash them to some order, right? That means that I don't have to check all the previous chains. I can just check the last hash here. Because if these hashes are the same, then the whole chain backwards is the same, because it's being built upon previous hashes that is included in each current hash. You can think about that for a while, what that means, but it means that I only have to check the last hash if it's the same as my hash. And if it is, we have the exact same blockchain. And if it isn't, we have two concurrent chains that both are valid, but since I don't know, here you can decide what you want to do. You can swap them around, doesn't really matter, but since it could be a situation where I'm currently mining something, so I prefer to keep my local chain until something is way bigger than my chain. I have no way of catching up. And I think the word catching up is a lead word here that we're gonna explore a little bit later, what implications that can give you. So with that being said, let's just fire up these two nodes and see. I hope you remember, you can pause the video and check the transactions that it makes if you get confused right now, because let's see what these two guys give you. So let's see what happens when they try to start doing communicating with each other. So okay, this guy, he has done something here. You have the blockchain here. I'm gonna pause them so the output doesn't disappear. But what happened here is you can see that node 1, it has a longer blockchain, right? Because it has like three transactions in it. And the node 2 only has 2 transactions. And here it starts up the server and stuff. And then here is node 1 received a blockchain from node 2. It doesn't do anything. Here it prints the balance of all the accounts. So the bank is minus 1200. The node 1 is minus 100. Node 2 is up 1300. Because, you know, node 1 is buying stuff from node 2. And both of these guys received money from the bank. And that is why it's down 1200. And so this is the balancing part. And then it says my blockchain is longer. You will have to wait for mine to be broadcasted. Because, yeah, you can send it back immediately, of course, but you could also just wait for it to broadcast it itself, which it does. And then it receives its own blockchain, which it doesn't do anything with, and prints the balance and saying we have the exact same blockchain. Yeah, of course you do. It's your own, right? It prints the balance, and then it keeps on doing that every 5 seconds, right? And the interesting part happens here in node 2. Because here, node 2 is starting up the server. It's receiving its own block list here, so it's going to sum up. You can see the balance here is not the same, because at this point, they have not yet communicated with each other. So here, node 2 only has its local balance of all the bank accounts. You can see this is different from this, right? It's not the same balance on the accounts at this point, because node 2 hasn't been communicating with node 1 yet. Then it says we have the exact same blockchain, and it's because it's broadcasting to itself, so you can ignore that. But here you can see that suddenly the node 2 has received the blockchain from node 1, so it's received the blockchain from this guy, right? And Also now, if you compare the balance after that, you can see that now the balances are in sync, because now they have communicated with each other and agreed on which blockchain they should be using for the transactions. And then it says, okay, you win. I merged your chain into mine because it was longer. Size does matter, turns out. And then it keeps on doing that for a while. And then I exited. So this is the basic gist of it. And I'm gonna pause right now, and I hope you guys liked it. If there is any questions, leave it in the comment section, and I hope to see you in the next tutorial. See ya.